upon by a constant force.
And a constant force or an external force. Yes, Stephanie earlier made mention of it. So a body will continue to be in a state of rest or in a state of motion with a constant velocity unless it is acted on by an external force. Don't forget, the first law is also known as the law of inertia. So which of the laws, Newton's laws of motion, is termed as the law of inertia is the first law. Then the second law, yes, anybody? The second law, Newton's second law of motion. Anybody? Alexandra, let somebody else try. Okay, so I have Pascaline. Pascaline, yes?
Newton's second law states that the rate of change of linear momentum of a body with respect to time is directly proportional to the force applied.
Thank you. Or, yes, we can also state it differently. Or, the gentleman, or, okay, let me see if we have, okay, Farida. The gentleman will come in, they will come in later. Farida, go ahead. Or
Newton's second law of motion states that acceleration of a body is directly proportional to the external force applied.
And inversely proportional to the mass. Okay, and inversely proportional to the mass of the body. So please add that. Is directly proportional to the external force applied and inversely proportional to the mass of the body. Then the third law. Yanis.
So please, the third law states that for every action, there is an equal but opposite reaction.
So for every action, there is an equal and opposite but opposite reaction. Use and rather. For every action, there is equal and opposite reaction. Let's look at applications. Can somebody help explain why the first law is also known as the law of inertia? Why is Newton's first law of motion also known as the law of inertia? Anybody? Why is Newton's first law of motion also known as the law of inertia? Okay, hey, Alexandra, Pascaline, hold on, let me give it to Alexandra. Yes.
Sir, it's known as the law of inertia because through its explanation it describes inertia as being the measure of the opposition of the change of velocity.
So opposition to a change in the velocity of a body is the measure of the body's inertia. So inertia of a body is the measure of the body's opposition to a change in its velocity. Okay. Now, if a body has a greater inertia, it will require a greater force to change its velocity or speed. And if a body has a greater inertia, it will also require a greater external force to increase or decrease its speed. So the inertia of a body would also continue to be at rest or be in a move with a constant velocity unless an external force is applied. Okay, so the mass of a body, the measure of a body's mass is also a measure of a body's inertia. A greater force or mass means that the body has a greater opposition to a change in its velocity. So last time I told you, consider two people, one slim and one fat. If both of them are at rest and you want to move them by a certain amount, you only apply a force on the slim person, and the velocity will change. The slim person would accelerate. However, the same acceleration, you have to apply a greater force on a fat person to accelerate by that margin. Equally, when the two are also running and you want to change their speed by stopping them, you have to apply a lesser force to stop the slim person. But the fat person, you must apply a greater force before. Okay, so a greater force is required to also change the inertia of a body. That is why the first law is also known as the law of inertia. Please, are we okay?
Yes, please.
Because you can be asked to explain why, a possible examination question. Explain why Newton's first law of motion. Please write that down. Explain why Newton's first law of motion is also known as the law of inertia. Explain why Newton's first law of motion is also known as the law of inertia. Then what is inertia? What is inertia? Inertia is the measure of the opposition to the change in velocity of a body. Is a measure of the opposition to a change in velocity or speed of a body. So a body with greater inertia will require a greater external force to change its inertia. All right, let's look at applications of the first, second, and then the third law. Applications of Farida.
Can you repeat the definition of inertia?
Inertia is a measure of a body's opposition to a change in its velocity or speed. The measure of the opposition to a change in the speed or velocity of a body. The measure of the opposition to the speed or velocity of a body is inertia. So applications of Newton's laws of motion. The first law is applied in the use of automobile seat belts or car seat belts. So the first law, Newton's first law of motion, is applied in automobile or car seat belts. how is that applied? Any nature is such that masses or objects with definite mass always opposes a change in its velocity. Okay, so long as the body has a mass, it has that tendency to oppose a change in its velocity. That is natural. So whenever you are in a car and the car begins to move, your natural tendency to oppose a change in your speed is that instead of you also moving along with the car, you'll be leaning back in your seat until the upholstery of the car seat or the car seat acts on you or pushes you to move in the direction or with the velocity of the car. Okay, so if you've been observant, when the car begins to move, you will be leaning back on your seat for some time before the seat would exert a force on you, and you'll be moving with the velocity of the car. Then when the car is moving and suddenly applies the brakes to stop, you also want to, by nature, we want to oppose this sudden change in our velocity. Applying the brakes means that you are being stopped. You oppose it by you jerking forward, your body will continue to move forward. Okay, so that is why the seat belt is always there, so that when there is a sudden force acting on you, either against you or in your direction, it would also oppose your inertia. So when you are in a car and then a car hits at your bumper behind, there is an external force pushing you forward. You would oppose it by going backwards or accelerating backward, okay, in the opposite direction. And don't forget, the extent with which you go backwards is directly proportional to the applied force on your car. So when the car hits at your back that much, you go backwards, okay, and your acceleration backward is directly proportional to the weight or the force which strikes your car. On the other hand, if the car is going and then somebody hits it from in front, you oppose. Hitting your car in front means that your car is suddenly being stopped. You also oppose this change in your speed by moving forward, and your accelerating forward is directly proportional to the force which hits your car. That is why usually when you are in a car, it is always advisable to put on the seat belts, because your acceleration backward or forward depends on the amount of the force which hits your car. Okay, and this is the reason why sometimes some accidents on our roads result in fatality, because passengers fail to put on the seat belts. They can accelerate forward even to the extent of being thrown out of out through the wind glass. Okay, so this is one of the applications of the first law. 2, if you are in a bus, you are not expected to just stand. Or if you are in a vehicle generally, this is because if you stand and there is a sudden brake, the driver's something crosses the car and there is a sudden brake, you will be thrown forward, and your acceleration forward, it will depend on the force applied. Class, are you there?
Yes, sir.
So that is why in a bus, passengers in a bus are always expected to, those who happen to sit, If you sit, you must use the seat belt. If you stand, hold on to that string, which is installed, okay, above you, so that it will cater for this sudden push or backwards movement in the event of anything. Then passengers even on a single decker bus, you are not supposed to just stand. How much more in a double decker? In a double decker, you just be thrown outside or forward, and you can move to hit seats and so on and so forth. So these are some of the applications of the first law. Please, is there any question? If you have any question, ask. If there is no question, we move on to the second law. Applications of the second law. The second law simply measures the extent of acceleration when an external force comes in. So practically the first law and then the second law are almost the same. The only difference is that in the second law, we are measuring acceleration in the event of an external force being applied. So it also has to do with acceleration of bodies in the event of applying an external force. We know that when there is no external force, acceleration is also zero. But when external force comes in, then bodies would accelerate. And this is how we can quantify or measure that. So, acceleration of a body is directly proportional to the applied force and inversely proportional to the mass of the body. Class, if two quantities are directly are related in such a way that they are directly proportional, what does it mean? When two quantities are said to be directly proportional to one another, what does it mean? Evans.
Sir, please, I think it means that if one quantity increases, the other also increases.
And vice versa. So if one quantity increases, the other would also increase. And if one quantity decreases, the other also will decrease. Can somebody share with us two real life situations where two physical quantities are directly proportional to one another? Can you give a practical real life situation where this relationship actually counts? What and what have that? Can we say time is directly proportional to a number of years on Earth? Class, can we say that?
Yes, sir.
Yes, sir.
Yes. Today is 1 day. Tomorrow, 2 days. When you go through 365 days, you have one whole year added to your years. So as time increases, your number of years or your age also. Oh, okay, this is as time increases, that fixed age of yours decreases. So this must relate to something else. We'll talk about when one is increasing, the other is decreasing. But then we can say that density and mass are directly proportional to one another. When mass increases, density also increases. But this is on condition that volume is constant. Volume is constant. So density is directly proportional to mass. What again? What other quantity? Okay, so whenever it comes to mind, I'll share with you. Then When two quantities are related in such a way that they are inversely proportional, what does it mean? A is inversely proportional to M. When two quantities are inversely proportional to one another, what does it mean? Anybody? Anybody? Yes, Enoch. Do.
It means that, for example, force is equal to mass times acceleration. If the mass is matched, the force will also be matched. But if the mass is less, the force will be less.
Enoch, we are talking about inversely proportional to one another. So here we are saying that acceleration is inversely proportional to mass. What does it mean by two quantities relating in this manner? Janice wants to also try. Janice, go ahead.
So please, I think this means that when one increases, the other decreases, and when the other decreases, the other increases.
Exactly. So class, when two quantities are inversely proportional to one another, as one increases, the other will decrease. And as one decreases, the other will increase. Okay? So from Newton's second law, acceleration is directly proportional to the applied force or force. But this is on condition that mass is constant, meaning you don't change the mass. It must be the same. So if acceleration is directly proportional to force, then for two different forces, there must be two different accelerations. So A1 must be directly proportional to F1, and A2 must also be directly proportional to F2. When you take the ratio of equation 1 and equation 2, you have ratios of accelerations and ratios of forces. So A1 over A2 is also equal to F1 over F2. So this is a formula which can be used to calculate either acceleration or force in the event that one changes. I'm going to help you understand by giving you a question. A force of 500 Newton, please write that down. A force of, Jasper, leave my word alone. No. A force of 500 Newton, accelerates a body by 2.5 meter per second squared. A force of 500 Newton accelerates a body by 2.5 meter per second squared. Determine the acceleration. Determine the acceleration when the force is tripled. Oh, please do not write on the screen. I beg you, it will disturb what we are doing. Determine the acceleration when the force is tripled. Determine the acceleration when the force is tripled. What does it mean by the force being tripled? Class, what does it mean? Class, what does it mean by the force being tripled? Jedediah.
It means that the force acting on the body increases by 3-fold.
Okay. Yes. Or is increased by 300%. So please, this should be a 1 minute 10. What is the acceleration when the force is tripled? Are we finished? Class, have we?
Yes, sir.
Okay, so what are your answers? Jedediah, give me yours. Francis?
So
Yes.
7.5.
You have 7.5.
Yes, sir.
Who else had a different answer? If you got a
Okay.
different answer, share it with us. I'm listening. Okay, I'm coming. Let me take a screenshot and get back to you.
Jesus.
Just a minute, okay? I'm coming.
Yeah.
So we have A1 over A2, which is equal to F1 over F2. A1 is 2.5. A2 is what we are looking for. F1 is 500. And F2 is 3 times 500. So 3 times 500. This 500 will cancel out. Therefore, A2 would be 3 times 2.5. And this is 7.5 meter per second squared. Please mark yourselves. And let's compare it to the theory. The theory is saying that when two quantities are directly proportional, as one increases, the other also increases. So force increased from 500 to 1,500, and the acceleration also increased from 2.5 to 7.5. So this question obeys the theory. Class, are we okay?
Yes, sir.
Are we?
Yes, sir.
Are we fine?
Yes, sir.
Okay,
Yes,
so
sir.
let's look at the other one. Acceleration is inversely proportional to the mass, meaning A1 must be the inversely proportional to M1, and A2 must also be inversely proportional to M2. Let's take ratios of accelerations and then mass. So A1 over A2 is equal to 1 on M1 over 1 on M2. Simplify the right-hand side for me. Elikem, Hubert. Yes, if you have a question, go ahead. Help me simplify the right-hand side expression. What will be 1 on M1 divided by 1 on M2? Yes, Francis.
Sorry, reciprocate. So you get 1 on M1 times M2 on 1.
But simplify it. Okay, you are right, but
Okay.
give me the
You get M2 over M1.
good. So this will be equal to M2 over M1. Please note that this is on condition that force is constant. Force does not change. So the force acting on the two masses must be the same. So a body of mass G kilogram accelerates by a meter per second squared. Calculate the acceleration when the mass decreases to 25% of its original value. So calculate the acceleration when the mass decreases to 25% of its original value. Try it. I've intentionally given you variables. When we finish, I'll give you numbers. Don't panic, okay? Hubert, your hand is up.
Sir, please, I want you to go back to the first this and I want to take a screenshot of it.
Oh, I'm recording.
Okay.
I'm recording, so I'll drop it in there. So don't worry. So those of you who are phobic to variables, don't worry, I'll come to your numbers, okay? Truly, when I was a student, I didn't like some of these variable questions. Finished?
Yeah, on it.
Okay. Okay, so time's sake. So we just established that acceleration is inversely proportional to the mass. So A1 over A2 would give us M2 on M1. So what is A1? A1 is A. A2 we don't know. That's what we are looking for. Then what is M2? Class, what is M2? Class, what is M2? We are told the acceleration, calculate the acceleration when the mass decreases to, so M2 is 25% of M1, it decreases to, please, are we okay?
Yes.
So it will be 25% of the initial mass M1, which is J kilogram. So this J. And 25% is 1/4 J. So M2 is quarter of M. So of J over J. Let me go systematically. M2 is quarter of J divided by M1, which is J. So in effect, J will cancel and the whole ratio will be equal to 1/4. So A over A2 is equal to quarter. Therefore, A2 would be equal to 4 times A. And look at something. When the mass is J, acceleration A, when the mass reduced to 1/4 of A, acceleration increased to 4 times A. So it also explains the theory that acceleration and mass are inversely proportional to one another. Let me make it real numbers. A body of mass 100 gram. A body of mass 100 gram. So M1 is 100 gram. Accelerates by 5 meters per second squared. Determine the acceleration. Determine the acceleration when the mass is doubled. Determine the acceleration when the mass is doubled. And when the mass is doubled, it will be 2 times the initial mass. So find A when the mass is doubled. Please, I've given you real numbers. So let's see. Papa, Francis.
Sir, 20 meters per second.
Okay, so when mass is doubled, acceleration must do what? Look at the theory. Acceleration and mass are inversely proportional. Meaning when one increases, the other would decrease. And when one decreases, the other must increase. So, Francis, look at it again.
Okay, sir. 200 over 100. 500.
Ejewa. Francis, have you finished?
Yes, sir.
What's your answer?
2.5 meters per second.
Does it follow the theory?
Yes, sir.
Okay, we'll probe, so don't worry. Class, can we discuss it? So A1 over A2 must be equal to M2 over M1. Please, the same equation can also be A2 over A1 must be equal to M1 over M2. Whichever way you look at it, the answer must be the same. So if A1 is 5 meters per second squared, so 5 A2 over 5 is equal to, what is M1? M1 is 100. and then M2 is 200. Therefore, A2 would be 5 on 2, which is 2.5 meter per second squared. Meaning, we see the mass increasing and the acceleration also decreasing. So it obeys the theory. Class, are we okay?
Yes, sir.
So arm yourselves. I'll look for more challenging questions. Where percentages, fraction, and all that, just to help you apply the knowledge in different angles. Please, is there any question? Want to move on to the third law. Application. Okay, before we look at the third law. So it is from the second law that we obtain if A is directly proportional to F and inversely proportional to M, then if we make F the subject, or if we introduce an equal to, we have A is equal to a constant of proportionality, F over M. If you make Kf the subject, you have Ma. When you consider the base unit of F, M, and A, you get the constant of proportionality K to be equal to 1. Therefore, F is equal to Ma. This is Newton's second law equation, which is used to determine a force acting on a moving object. If you use the other definition, force is directly proportional to change, the rate of change in momentum, delta P, with respect to time. Change in momentum, delta P, is equal to M, the product of the mass, and then the difference in velocities. So when we substitute it, we have F is equal to K, let's put M into bracket V minus U in place of delta P. We have M V minus U all on T. Class, from linear motion, what is V minus U all over T? What is V minus U all over T? Enoch?
Acceleration.
This is acceleration, A. So when you substitute A for what is V minus U all on T, you have K, Sean, I'm coming, M times A. And when you take the SI unit, the base unit of force, which is kilogram meter per second squared, base unit of mass, which is kilogram, base unit of acceleration, which is meter per second squared, you also have K to be equal to 1, and F is equal to Ma. So whether you consider the first definition or the second definition, you get this. Yes, Sean, your hand was raised earlier on.
Also,
Okay. The ladies, are you there? Are you all following?
Yes, sir.
You are not a lady.
Yes.
The ladies,
Yes,
let me hear your voices. From Ama to Adjoa. Okay.
Yes, sir.
Applications of the third law. Yes, I want you to share what you know with me of the third law. How do we see Newton's third law of motion being applied in real life situations? Abdul Rahman.
Sir, please, shooting of gun.
the shooting of gun. Okay, or instead of shooting of gun, let's say shooting of bullet. Okay, or shooting a bullet. Jocelyn.
Sir, please, swimming.
Swimming. Swimiology. During swimming. Sean.
Sir, please, a bird when it's flying, flying its wings, flapping its wings.
Flapping the wings. Okay. A bird.
Sir.
I'm coming. Flapping the wings. You all explain. Gender balance. So let me. Inshiraminta.
Sir, please, rocket propulsion.
Inshiraminta is a male. Okay, come. Inshira, go ahead.
Sir, rocket propulsion.
Okay. Okay, rocket propulsion. Or launch, or instead of launching a rocket. Or launching of rocket. Launching of rockets. Is that all? Yes. Evans. Or Jocelyn. Evans, what did you say?
Jumping.
Jumping.
Yes,
Jumping. Okay, even walking. Okay, even during walking. Running, jumping. When last one by Francis.
Yes, sir.
Or your hand is not raised.
Sir, it's not raised.
Paddling a canoe. We can see a lot. It's okay. So let's see. Shooting a bullet. Shooting a bullet. Who said it? Where is the bullet shooter? Go ahead. Explain.
Sir.
How does
When you shoot a bullet,
yes,
you exert a force on the bullet. There is a force that exerts on the bullet.
So spring force acts on the bullet to move it. And then
to move it, it also exerts force on the gun.
And on the holder. Good. Yes. So that is the reason why, you see, if you're in movies, oh, please pay attention and listen. Francis, I'll beat you from your house. Let me mute. Oh. So if you've been observant during movies, even when the pistol is being fired, it must always be done with two hands. Else, whoever is doing the firing can miss the target. Because the moment the bullet just escapes from the barrel, it exerts a reversal force on the hand. So if if you are not gripping it well, it can move your hand and the target can be missed before you realize you have shot whatever you never planned shooting. So that is the reason why they fire even a pistol, which is the smaller kinds of arm with two hands. Then when it comes to the bigger ones, AK-47, you must grip it in such a way that it even makes contact with your body, because if it shakes you, you can easily miss your target. Then when it comes to the those bigger ones, it must always be done by two people, else problem. So that's the reason why. During swimming, how does Newton's third law comes in during swimming?
Sir, please, the swimmer pushes the water backward, and then the water pushes the swimmer forward.
Exactly. So whilst you drag the volume of water with your feet and your foot, it also exerts a reversal force on you. And that is how come you'll be moving forward. If you don't apply those tricks, you'll just be lying flat, and then the sharks will come and devour you. Okay. Then the flying of birds is also similar to when we are swimming. Okay, they also flap their wings and their feet, and as a result, exert a forward force on them. Launching of rockets in space. Yes, if you've watched how rockets are launched from the Earth, you see, there must be huge burning in the engine of the rockets, and when the fume escapes, okay, the fume, similar to escaping fume from cars, when the fume escapes, the force and the momentum with which the fume escaped exert a reversal force on the rocket, and that is what projects it forward. The greater the fume escapes, the greater the forward movement of the rocket as well. During walking, you see, when you are walking, your foot, the muscles contract, okay, exerting a force on the ground, and the ground, by friction, also exerts a contact force, reversal contact force on you, and that is what pushes us forward. Okay, during walking, the same thing. During jumping, paddling the canoe, yes, paddling the canoe is just like you are swimming in water, okay? So whoever drives the canoe pushes the volume of water in one direction backward, and there is that reversal opposite force acting on the canoe, and that is what moves it. Justice, your hand is up.
Yeah, sir, please. Can we say a flying plane to its part?
No, plane is moved by the engine. So as for plane, the passengers and the plane by itself doesn't do anything. For canoe, you must pedal it to move. But the plane, once the engine is ignited, it exerts a force. The plane is just like
the rocket.
Cars. Okay. Cars, yes. The burning within the engine exerts the force. But we are talking of situations where you must do the work to exert that reversal force on you.
Yes.
All right.
Sir.
Hello.
Sir, please. Sir, please, I can hear you. Sir, please, I have another question. But,
okay, go ahead.
Sir, upon what you are saying, the engine is the one that is making the plane move, so it isn't part.
You see, the engine.
But the rocket too, the one who is launching it doesn't exert any force on the rocket for it to move.
In the case of the rocket, you see, yes, there is an engine, fuel must be burnt within the engine and then intentionally made to escape, okay, downwards. While the fumes escape downwards, that opposite force is exerted. Yes, I agree with you, because for cars, yes, the same thing happened. The fume escaping from the exhaust pipe doesn't contribute, because here the force must be greater than friction on the road. In the case of the plane, as the fumes escape, there is a forward force which is exerted on the plane, okay, on the plane. And in the case of the plane, the escaping gas also helps, but the emphasis is not so much on the escaping gas. Okay, for rocket, yes. For the rocket to move with that continuous speed, the gas must escape with that velocity. The technology of the plane is different from how the rocket is designed. Are you okay?
Yes, sir.
Sean, last question. We have a lot to do. So Sean, last question, then we move on. Or Evans. Evans.
Sir, please, I have a question. I have a question on the Newton's second law of motion.
Okay. Go
Sir,
ahead.
please, how did you get the value of T after finding the unit?
Oh, I said that, you see, you have F. You know, if A is directly proportional to F and inversely proportional to M, when you introduce an equal to sign, there must be a constant of proportionality, K. Therefore, KF or FK must be equal to MA. When you take the base unit of all, what's the base unit of force? Class, what's the base unit of force? Let's not waste time. Base unit of force. Oh, class, we've done dimensional analysis. So this thing, please do not waste time. What's the base unit of force?
MLT raised to the power negative 2.
Base unit, not the dimension of force.
Okay.
That is kilogram. You are wasting time. Oh.
Kilogram meter per second squared.
Good. Kilogram meter per second squared. So times kilogram meter per second squared is equal to the base unit of mass, kilogram, times base unit of acceleration, meter per second squared. So you realize that kilogram meter per second squared, kilogram meter per second squared. And so K is equal to 1. So when you consider the base unit of all the quantities, you have the constant to be equal to 1. And so you can conclude that F is equal to MA. So whoever asked the question, that is it. All right, let's look at how we can apply Newton's second law in particular to solve questions. And I'm going to give you a question, so we try. Just give me a minute. Okay, a body, Farida. Farida.
Yeah.
Did
you say Newton's second law of motion or Newton's third law of motion?
Second, we are applying Newton's second law to solving questions. First and second, actually. A body is at rest under the action of the forces shown in the diagram. A body is at rest under the action of the forces shown in the diagram. Let me quickly sketch the diagram. So this is on first and second law. The first and second are not different. In Shiraminta.
Please, can you repeat the question again?
A body is at rest under the action of the forces. A body is at rest under the action of the forces shown in the diagram. Yes, under the action of the forces shown in the diagram. Find the value of A. Find the value of A. Yes. Stop quarreling on a platform. If your video is on, please off it in order not to, create that attention on you. Evans, you are done.
Yes, please.
What is your answer?
I go 41 Newton.
You explain. So let's wait for your other colleagues. I'm giving you another one. This is 500 Newton. This force is X. Then we have two downward forces, 1,240, and another 450. Then we have this force U west, which is 500 Newton. Find the value of X. Abdurrahman. So, hold on. So this is a question 2, this is a diagram. The question under it is this. A body moves horizontally at a constant speed of horizontally at a constant speed of 4 meters per second under the action of the forces shown. Under the action of the forces shown. Find X. Find X. So those of you who are through with the first one, what is your answer? Yes, the value of A. Rahman, Abdul.
41 Newton.
41. Stephanie, what is your answer?
Sir, please, 41 Newton.
41. Okay. can somebody explain how did you get 41? I also agree that A is 41, but how did you get 41? Abdul Rahman.
Sir, before we got our answer, you said the object is in constant motion.
Yes.
It's at rest. So which means before an object should be at rest, the force at both sides should be equal.
Abdul, listen to a body is at rest under the action of the forces shown in the diagram. So it's not in constant motion, but it's at rest. It's at rest under the action of the forces. So if it's at rest, what do we do? Anybody else to also share what he or she thinks of the question with us? Anybody? Okay. No, go ahead.
So I think it's the equilibrium of force.
Okay. Thank you. You see, Newton's first law is saying that a stationary body would continue to be stationary. And a moving body, a body in motion, would also continue to move with a constant velocity. Unless what happens? Unless what happens? Class, unless what? Yes, answer from your homes.
An external force forces it to act
Good.
otherwise.
Good. So once, okay.
Upon by an external force.
Okay, thank you. So once it is stationary, it means that it is not moving. And if it is not moving, by Newton's second law, it means there is no external force acting on it. There is no external force. The external force is termed as net force, resultant force, okay, or an unbalanced force. So if it is stationary, then there is no external force, meaning that if we look at the total forces in all directions, the sum of the total forces in all directions, it must be equal to 0. And this is what we call as the body is in static equilibrium. Static equilibrium. So what is static equilibrium? In static equilibrium, the total forces acting on a body in all directions is 0 and the body is at rest. Class, did you hear that?
Yes, please.
In static equilibrium, the total forces acting on a body in all directions, the total forces acting on a body in all directions is equal to 0 and the body is at rest. That is static equilibrium. So if the body is in static equilibrium, then total upward forces must be equal to total downward forces. Total eastward forces must be equal to total westward forces. Okay? So, A plus 45 must be equal to 86. This is because the body is in static equilibrium. So the forces in all directions must be the same. So if A plus 45 is equal to 86, then we can say that A is equal to 86 minus 45, which is equal to 41 Newton. Please, is there any question? Manuela, is there any question? Yes, yeah. Okay. Let's look at the second question. Attempt the second question and come and explain to me. In the second question, we have a body moves horizontally at a constant speed of 4 meters per second under the action of the forces shown. Find X. At a constant speed of 4 meters per second under the action of the forces. Find X. Mamiya, I'll be interested in your answer. X. Then Mavis, Annaba, Moscow. I'll also call you to give me what you have. Then lastly, Kingsley Aka. I'll come to your home for the answer. Kingsley Aka. Mamiya, what's your value of X?
Sir, please, I cannot see the numbers.
Oh, 500 due west, 500 due east. Then 1,240 Newton due south and another 450 due south. Then due north is X. Okay. Are you okay?
Yes, sir.
Mamiya. Kingsley. Mavis. Yeah, let me hear from those individuals whose names are mentioned. Mavis. Mavis, are you there? Mommy, are you there? Kingsley, are you there? Oh, network cannot be reached. Anybody else?
Sir, please, I'm here.
Mommy, let me hear from what is your value of X?
Please, sir, when I added the 124 to the 45, I got 169 Newton.
So you think X is 100 and what?
69, sir.
No, it's I think 1,000. It is 1,240 and 450. Okay. Abbas.
Oh, okay.
Sir, please, 1,690 Newton.
Okay, so
1,000.
Yes, X is, X will be 1,690. But what is the reason? Why are you equating the force due north, which is X, to the forces due south? What is your reason? Anybody? Okay, Abbas, your hand is still up.
Sir, please, the body cannot move west or east because the force is the same. The force at both sides is the same. But when the body acts on, Abbas,
hold on.
Southward.
Abbas, hold on. The question is saying that a body moves horizontally at a constant speed. So if you are saying the body cannot move north or east or south, I disagree with you. Abbas, do you understand my question?
Yes, please.
Okay. Anybody else to share what he or she thinks with us? Why are we equating X to the sum of the downward forces?
That please me.
Okay, Mamia.
That please, I think that because the body is moving at a constant speed, it's not slowing high or it's not slowing down. So for that matter, we add double forces to get the one.
The answer is correct. Explanation incorrect. Ejewa. Last one, Ejewa.
Answer. Because
Ejewa, let's use the time word.
object is moving at speed.
Mm-hmm.
The forces below should be the same as the one above in order to maintain the speed.
Okay, let me also come in. All right, so thank you for your contributions. Now, you see, Newton's first law is a kind of two-in-one. A body can be stationary when the total forces acting on it is zero, and a body can also move with a constant velocity when the total forces acting on the body in all directions is zero. What we are having is force under the second part of Newton's first law. Okay, listen to the law. A stationary body will continue to be stationary, and a body in motion would also continue to move with a constant velocity unless an external force acts on it. So if there is no external force, then it means the body can either be stationary or move with a constant velocity. Okay, and if there's no external force, it then implies that all the forces acting on a body in all directions are equal. So when the body moves and it has a constant velocity, it falls under what we call dynamic equilibrium. The body is in dynamic equilibrium. So in a dynamic equilibrium, the total forces acting on a body in all directions is equal to zero, and the body moves with a constant velocity or speed. Class, are we okay? Class, are we okay?
No, sir, please, I don't understand.
In a dynamic equilibrium, the total forces acting on a body in all directions is equal to zero. Or yet the body moves with a constant velocity. So if the body is moving horizontally at a constant velocity of or speed of 4 meters per second, then it means the body is in a dynamic equilibrium where the net force or total forces on the body is equal to zero. So that is why when we look at it horizontally, 500 is equal to 500. So it means that vertically, X must also be equal to 1,240 plus 450. Mamiya, Abdul, and the rest of you, are you okay?
Yes.
Yes, sir.
Now, if another explanation, if the body is moving at a constant velocity, what is the value of the acceleration? If the constant velocity is 4 meters per second, what is the value of acceleration, Francis? Zero. In Newton's law, if acceleration is 0, what does it mean? If a body does not accelerate, what does it mean?
Velocity is constant.
Or in Newton's law, velocity is constant, yes, that's what we've just said. In Newton's law, if a body does not accelerate, what does it mean?
The body is in rest.
The resultant force is 0.
The resultant force is 0. So it is for that reason that we are equating vertical forces. They must be equal because the body is not accelerating. And the icing on the cake would be a question on acceleration. I'm reading, please pay attention and put this down for me. A body of mass 20 kilogram, a body of mass 20 kilogram is being pulled along the floor, with constant velocity, by a horizontal force of 140 Newton. 140 Newton. Find the normal reaction. Enoch. Enoch Do, your hand is up. I'm going over.
Sorry.
A body of mass 20 kilogram is being pulled along the floor with constant velocity by a horizontal force of magnitude 140 Newton. Find the normal reaction on the box. Find the normal reaction on the box and the frictional force between the body and the box. And the frictional force between the body and the box. I'll give this as an assignment to you. So you will solve this. So we can try a question on acceleration. So you are looking for the normal reaction and the frictional force between the body, the body and the floor.
Sir, please, the question again. My network.
Please pay attention. A body of mass 20 kilogram is being pulled along the floor with constant velocity. Constant velocity, very, very important. With constant velocity by a horizontal force of magnitude 140 Newton. 140 Newton. Find the normal reaction acting on the box and the frictional force between the body and the floor. So I'll repost this on the page because it's an assignment which must be submitted today. Do not solve it, okay? I'm giving you one which we'll be looking at before we close the day. Good. Forces act on a body as shown. Forces act on a body as shown. And this is...
Sir.
Hello.
So please, this is a different question.
Yes, this is a different question. We'll solve this before we end today's class. Forces act on a body as shown, giving rise to the acceleration of. Forces act on a body as shown, giving rise to the acceleration of 1.5 meter per second squared. Forces act on a body as shown, giving rise to the acceleration of 1.5 meter per second squared. This is 17 Newton. So two forces due east. This is 24 Newton. Then this is 3G. G is gravity, Newton. Then we have normal reaction force R. Now the question is, find the vertical force R. Find the vertical force R and the horizontal force P. The body accelerates by 1.5 meter per second squared. Find the vertical force R and the horizontal force P. And horizontal force P. We are told the acceleration of the body is 1.5 meter per second squared. Class, this time around, there is acceleration of the body. There is an acceleration of the body. And when body accelerates, there must be an external or a resultant force applied. So this time around, because the body accelerates, the resultant force must not be equal to 0. One must be greater than the other. And the body is accelerating due right or due east. Look at the direction of acceleration. Okay. Meaning vertically, there is equilibrium. So the value of R, okay, because there is equilibrium vertically, it means R must be equal to 3G. G is gravity, so we can take R to be equal to 3 times 10 meter per second, which will be 30 Newton. But horizontally, a body accelerates due east. It means the sum of the forces due east must be greater than the sum of the forces due west. So when I put together P or sum of P and 17, it must be greater than 24. Class, are you with me? This is because the body accelerates. A practical application of this is during tug of war, the now tug of peace. When some set of people pull from one direction and another set of people also pull from the opposite direction. Whoever wins the tag must be those set of people who would apply a greater force than the other. So you realize that those who would apply lesser force will be pulled in the direction of the larger force during tug of war. So acceleration is always in the direction of the larger force. Class, are you following the explanation?
Yes, sir.
Yes,
So
sir.
if acceleration is due east or right, then it means P plus 17 must be greater than 24 because acceleration is due right. Sean.
This was my mistake.
Okay. So let's determine the resultant force. From Newton's second law, just mute yourself. F is equal to ma. The resultant force is this, and the resultant force is what does what is responsible for the acceleration. Don't forget F is directly proportional to A. So if the mass of the body is 3 kilograms, let's find out why the mass is 3 kilograms. We are told the weight of the body is 3g. Weight always acts downwards. So the weight of the body is 3g Newton. And we know weight to be equal to mass times acceleration due to gravity. So if the weight is 3g, 3g is equal to mg. G cancels out, and m is equal to 3 kilograms. So the mass of the box is 3 kilograms. So 3 times the acceleration. The acceleration is 1.5. So it means that the net force which is causing the acceleration is 4.5 Newton. So when you subtract the larger force, which is P plus 17, when you subtract the lesser force 24 from this, the difference must be equal to the net force, the net or the resultant force which we have calculated. Okay, so P plus 17 minus 24 must be equal to a resultant force of 4.5. Therefore, help me find the value of P. Class, quick one, Farida.
Sir, please, I don't get it.
So, Farida, is the body accelerating?
Yes, please.
Good. Body would always accelerate in a direction that always applies a greater force. So it is accelerating to the right-hand side, meaning the sum of the forces here must be greater than the force 24 Newton. Farida, are you okay with this?
Yes, please.
Now, if I sum total forces due right, P plus 17, and subtract the lesser force 24, the difference must be equal to the resultant force or the force which causes the acceleration. Viveka.
Sir, please, you wrote P plus 7.
Okay, thank you. P plus 17. The difference must be equal to the applied force, the external force. Farida, are you okay? Class, yes. Are you okay at this point? Newton is saying that every applied force or external force is equal to mass times acceleration. The weight of the body is 3g Newton. So if weight is 3g, and we know weight to be mass times gravity, then the mass of the body will be its weight, which is 3g, divided by acceleration due to gravity, g. And so mass of the body is 3 kilograms. Knowing the mass, we can be able to calculate that force which accelerates the body. So 3 kilogram times acceleration, which is 1.5, would give us the resultant force or the applied force, and that is 4.5. Okay, so P plus 17 minus 24 must be equal to the applied force, which is 4.5. And P would be equal to 17 minus 24. What is 17 minus 24? 7. 7 plus, so negative 7. Okay, negative 7. So you have P minus 7 is equal to 4.5. So that P would be equal to 11.5 Newton. Please, are you okay? You see, because we have
Yes,
about
sir.
4 minutes, that is why I'm running. But Farida,
Sir.
When there is a chair and then you push from one end and your brother also pushes from the opposite end, the chair would move only when one of the pushing forces is greater than the other. If the forces are equal, the chair will not move, meaning acceleration is 0. Are you following it?
Yes, please.
So if you push with maybe 15 Newton of force, and your brother also pushes from the opposite end, 10 Newton, the difference between your force applied and your brother's force is what will cause the acceleration of the chair. So 15 minus 10, meaning the applied force which will accelerate it is 5. That is exactly what we are doing. For the box to accelerate by 1.5, then the difference between P and 17 and 24 is what is responsible for the acceleration. Then we use this formula to calculate the applied force which will accelerate the tear. And getting that will help us find the value of P. So tomorrow I'll give another question, okay, and then we apply. And I think it will be clearer with other examples, real life situation examples, and it will be okay. Please, are we fine? Ivan?
Yes. Yeah.
Yes,
Sir,
Ivan.
please, I have a question.
Go ahead.
Sir, please, in the question, you didn't indicate whether the acceleration is due is or not.
Oh, I
so
did.
how will you know that?
Evans, I did. You look, this is it.
Sir,
Let me change the color, and then you see, this is the arrow for the acceleration, isn't it? Can you see from the board?
Yes, please.
So I indicated the direction of the acceleration with the arrow, 2 arrows.
Okay.
Are you fine?
Sir, please, will the diagram be given to you?
Oh, here, for this particular question, I've given you a diagram. In some other questions, there wouldn't be a diagram. So tomorrow we'll solve another question where there wouldn't be diagram and we'll see all that. So relax, okay?
Okay.
So by this diagram, the body accelerates due right or due east, meaning that the sum of the forces acting due right must be greater than forces acting in the opposite direction. For vertical, there is a balance because the body is accelerating horizontally, meaning it's not going vertical. Please, is there any other question? We have just 1 minute to end the show. Is there any other question?
No, sir.
Ladies, Stephanie.
Yes, sir.
Any question?
No, please.
I've given you assignment. So you do it and submit it for today. This is very simple. I want to see how you can apply what you've learned today. Tomorrow, we'll look at another situation and we'll be fine. Enoch.
So please, what's the deadline?
Pardon?
Please, what's the deadline for the submission of the assignment?
Oh, just submit it before our time, okay, for classes. Maybe around by we will meet for 1:30. So tomorrow morning will be fine. Mavis.
Sir, please, will you post the home? Yes, sir.
Will I?
Will you post the homework on the group page?
Yes, I will.
Thank you.
I will. I'll do that right after the class. Okay, so it's exactly 3:15. Class, this is where we end today's show. Please go over, okay? Find time. I'll put a question. So use whatever we've done for today. Go over, and when you have issues, do not hesitate to send me WhatsApp message. I'll respond to it because your success is my concern. Until tomorrow, may the good Lord take care of you, and bye-bye. Those of you who are fond of writing on my board, don't forget I will upload this video. So you are actually causing your own problem. Do not write on the board. It will show in the video. Okay, bye-bye.
Bye.
You are still writing. Pascal and bye-bye.